Okay, cool. There we go. Good afternoon, everyone, and welcome to Escape 2022. It's good to have you all here, both physically and remotely. My name is Andre Prinsloo, and it only took me working for BBD for about 6 years to work up the guts to come and do an Escape talk. The views of JavaScript in this talk is the opinion of mine and my teams. You are allowed to disagree. You are allowed to have your own wrong opinions. The cloud. I'm sure the term evokes a variety of different emotions in all of you. Some might experience excitement and eagerness, like setting off on another grand adventure. Others might experience regret and maybe some dread for the sins of software past. This is where our journey begins. My journey with the cloud has been a very interesting one. While working for many different clients on multiple different projects, I noticed 3 attempts at trying to adopt cloud. Initially, we tried lift and shift, moving existing on-prem solutions into the cloud. This was not a very successful approach, as these systems were likely running on beefy on-prem rigs cobbled together over many years, so they weren't particularly efficient. These grotesque Frankenstein systems require hundreds of gigs of RAM and enough hard drive space to put your new folder to shame. You know the one. This approach was not very cost effective. Our second attempt was designing apps to run in the cloud. For the most part, these were microservices running in EC2 or any weird and wonderful combination of lambdas and step functions. For the most part, these were not optimized for the cloud, as we did not yet understand what we were optimizing for. These solutions do, however, have their place in the cloud, but they aren't optimized to leverage the cost and performance tricks of the cloud. The third attempt was the exciting bit, and the topic for today's talk. Developing systems for the cloud that leverage all of the power and cost-cutting tools of the cloud. So, what is cloud architecture? Think build more, manage less. Serverless architecture is a cloud-native development model that allows developers to build apps quicker and run these systems without having to manage infrastructure. Let's take a look at 5 considerations when looking at serverless architecture. First things first. Contrary to the name, there are actually servers in serverless. However, these have been abstracted away from developers and are managed by the cloud provider, decreasing time spent on infrastructure configuration and management. Secondly, it lends itself to asynchronous or event-driven backends. Let's liken how async systems work to how you would expect snail mail to work. So, your friend has some free time and decides to send you a letter. The postman collects and delivers that letter to your mailbox. When you have some time, you check the mailbox and grab that letter. You read it and you write your friend a response. You send that letter back to your friend through the postman. That's how async systems work in a nutshell. In our example, you are the function executing work by grabbing letter, reading it, and replying to your friend. The postman is the protocol used to put messages onto the queue. The mailbox is the queue where messages end up waiting to be processed. And your friend is the client, initiating a request, going about their day-to-day activities, and periodically checking the mailbox for your inevitable response. Third, building on to our snail mail example, serverless allows you to rapidly add more mailboxes and more mail readers should your app get particularly chatty. Serverless also decreases these mail readers and mailboxes should your friend decide to stop sending you letters. This scalability is particularly impressive and one of the main reasons to look at serverless architecture. Fourth, given our ability to scale rapidly, one of the core principles of serverless is that you only pay for what you use. Think pay as you go. So a couple of years ago, we had some construction at our house. Not having to pay the water bill, the construction crew, of course, were extremely liberal with their usage of the hosepipe. At one point, I'm pretty sure they were running a car wash out of my driveway. Even though we had a water meter installed, our bill was calculated using math and algorithms, with no one actually coming to check the meter reading. That was a particularly rough month in the Prinsloo household. I swear, one weekend we were walking past a pond and ducks were throwing bread at us. The knoppy doesn't work. So with serverless, the cloud providers actually come to check the meter reading. This is the way of the modern world. No long-running contracts and no hidden fees. You only pay for what you use. No bullshit. And last, but by no means least, serverless architecture lends itself to bespoke or tailor-made backends. So these are backends that are made to solve a specific problem for a specific consumer. We're not building reusable components here. So throw away your programming principles textbook. We're going rogue. Because of the function concurrency limits, we can normally only have a set amount of functions running in a particular account. This limit seems to be about 1,000. However, these limits can be increased by request. And because of the design approach, these functions are units of work that again solve a specific problem in a specific context. To keep these functions as small as possible, we don't have overloaded methods that solve for every possible scenario for every possible consumer, just what we're dealing with in that instance. So Deloitte, who most of you should know, released a paper in 2019 around total cost of ownership of traditional backends and cloud backends, cloud serverless backends. Hold up, whoa. What is total cost of ownership? Total cost of ownership is the sum of all costs associated with IT projects and services. So let's nerd out a bit. Here's some stats that I found interesting from that paper. 6,000 IT companies that work with Deloitte took part in this survey. 19% of them were already running serverless apps as of 2019. Deloitte predicted that by 2021, this number would increase to about 42% of all companies surveyed. Applying some Google foo, I was able to get some supplementary data for 2021 from AppForge and Datadog surveys. The estimated usage across all AWS accounts was actually closer to 50% in 2021. The usage of serverless functions saw an overall increase of about 3.5 times. And the mean invocation time for these functions dropped from 130 milliseconds to about 60 milliseconds. This indicates developers got better at implementing serverless functions and applying serverless principles. So from that survey, what clients thought they would get from switching to serverless architecture was faster time to market, so less time between you starting dev and going to production. Dynamically scaling systems, so automatic scaling at no additional effort. Hands-off infrastructure management, just add coffee. A pay-as-you-go cost model, and an overall reduction in costs. Comparing two real-life scenarios, Deloitte came to the following conclusion. When looking at infrastructure in isolation, backends running on EC2 were more cost-effective in both scenarios. But both the other metrics were noticeably lower. When you account for development and maintenance costs, serverless became significantly cheaper, seeing a total reduction in costs of between 45 and 80%. Deloitte finished by summarizing that time spent on maintenance and ongoing operations were diminished for serverless applications. Serverless provides near infinite scalability and built-in high availability, which are additional costs and effort in traditional backends. So although the infrastructure cost was cheaper in a vacuum, organizations can save significantly by effectively leveraging serverless applications. Now that we have that sorted, I think it's important to note that these concepts and components are shared across all commonly used cloud platforms. So what is serverless framework? A problem we face near every day is people confusing serverless architecture with serverless framework, mainly due to the misguided naming of the framework. Serverless architecture is the development model we just discussed, and serverless framework is the set of tools that aid us in developing these applications. Serverless framework gives us 4 things. First, the ability to write human-readable config and store that as part of our project. So it's safe to assume that most of you know some HTML and maybe a little bit of JSON, but are you familiar with their stick-up-the-bum cousin YAML? YAML is a data serialization language that is human-readable and often used for config files. YAML is also the configuration language of choice for serverless. There are alternatives, and some of these are more powerful, but given the simplistic nature of serverless services or serverless backends, you might not necessarily need all that power. Our YAML config is stored as part of our project repo and is cloud provider agnostic, meaning I can deploy the same project to AWS, Azure, Google Cloud, and most other widely used cloud providers by simply adding another line to the config file. Second, being the earliest serverless development platform, a large community exists with a wealth of knowledge to draw from. A large community means loads of people making loads of mistakes and plenty more trying to solve them. And you know what that means. Ample opportunity for you to copy their solutions and claim the credit. Thirdly, the community continuously drives the adoption of new features, while also extending the framework through a rich library of plugins. These come in a variety of different flavors, from those allowing for the offline emulation of many of the cloud components, to the one that lets you develop your code in TypeScript, if masochism is your cup of tea, of course. Fourth, the ability to debug serverless apps locally. So, for those of you who haven't been around for that long, many years ago, we didn't have the cool, handy debugging tools we have today. You'd find a bug, stop your running app, and write some code to try and fix the issue. Kind of like throwing darts at a dartboard, blindfolded, and the dartboard's moving, and you're moving, and the room's spinning. You get the point. Just when you think you've got it, you run your app again, and bam! The issue is still there. Rinse and repeat ad infinitum. We started doing something we affectionately called caveman debugging. Caveman debugging is pretty much adding console logs at various points in your application, running said application, and seeing till what point your messages show up. This helps narrow down where your issue might be, or gives you some visibility on variables you otherwise had no means of debugging. So in 2018, we started work on a new project alongside a hotshot team of UK devs. UK devs. I'm allowed to make that joke. My wife's half British. So imagine my surprise when we were told to use caveman debugging on this project. It was a massive step backwards, but the tooling just wasn't there yet. Serverless framework toolset has kind of resolved this debugging issue for us. It allows us to run the code locally and step through this code when we need to do some inspection. There are still limitations when it comes to remote debugging. So the approach for now has been to be very smart with our implementation of logging. So what is serverless architecture not? Even though we're all looking for the goose that lay the golden solutions, serverless is not that. In Swedish folklore, silver bullets were a catch-all weapon against creatures and wizards that go bump in the night, a seemingly magical solution to difficult problems. Serverless is not that silver bullet. Software engineers have many tools in their belt. Serverless is just one tool in that belt. Therefore, not every problem can be a serverless problem. It's come a long way, but monitoring and alerting is not yet a solved problem. We are very reliant on verbose debugging, verbose logging, and we have no reliable way to dashboard the overall health of our systems yet, but we're getting there. We can pull metrics and create tables that display the overall condition for individual functions. But you all know business likes pretty colors. Serverless does not do well in synchronous environments. If a function needs to remain running, waiting for another synchronous process to complete, you will be billed for the time your function remains idle. Functions also have a set timeout. So the longer your function remains running, waiting for this synchronous process to complete, the closer you get to running into these timeout issues. What we've seen teams do is try to leverage state machines and functions to try and orchestrate how these synchronous processes go. This, however, is a very slippery slope. There are legit scenarios where you'd want to use state machines, but for the most part, these have been a crutch and is usually indicative of bad design. While it is true that serverless can scale near infinitely, there are some caveats. Sure, you can scale, but at which rate? This is limited at which rate you can scale. Burst limit is the term AWS uses to describe the total amount of functions that can be running at a single. Let me take a sip of water there. Burst limit is the term AWS uses to describe the rate at which you can increase your total number of concurrent functions. Recently, on a very chatty app, we were confronted by this reality that the burst limit in South Africa is set to 500 functions per second. So if traffic to our app would pick up very suddenly and we reach our 1,000 function concurrency limit, we'd only be able to scale that by 500 per minute. This forces you to think and engineer differently. Another concern around scaling is, can your upstream services keep up? You might be able to scale really well, but are your upstream dependencies going to be able to service that amount of traffic? Lastly, serverless is not good at long-running, compute-heavy tasks. So remember earlier when I said microservices running in EC2 still has their place in the world? Well, that's because these types of solutions are still better equipped to deal with tasks that require high amounts of memory or high amounts of CPU usage. So what about our story? We started as a team of 2 with fairly little experience implementing serverless backends. However, we knew how to write good JavaScript. Yes, Dieter, it does exist. So before I started working with serverless, I was by no means an expert. At times, I felt overwhelmed at this daunting new adventure that lay before me. So before I got into the thick of things, I made sure to understand the problem I was brought on to solve, but also whether or not that solution, the proposed solution, was the best solution for the job. I reached out to a few of my mentors in BBD and people I knew had worked with serverless before. I asked them everything I could to better understand the problem and the solution. We went through what worked well for them and where they found serverless shines. But also, and maybe more importantly, where they had hiccups with serverless and where they felt those shortcomings were. Leveraging their insights, I compiled a list of do's and don'ts. We made some of our own mistakes along the way, but saw these as opportunities to grow. And we added these lessons to our do's and don'ts. Being that serverless is a new way of thinking about solutioning, we found ourselves having to convince and reassure the client, and sometimes ourselves, along the way. But in the end, we were able to successfully land 3 serverless projects with a bunch more on the way, this time helping other teams achieve the same levels of success that we were able to. I recall one particularly anxiety-ridden day where I asked ATC for some help explaining the concept. I got a meeting invite from Tony and thought he would be assisting me. When I joined the call, the whole of ATC was there. A gallery so big, I thought they couldn't be there just to discuss my topic. But no, they were all there to help me make a success of the task at hand. It was this amazing response that made me understand the value and power of working for a company such as BBD, with all of the breadth of knowledge of its staff. My team and I would love to pull a page out of Bill Gates' playbook and claim all the success for making serverless work. But we had a lot of help from our colleagues within BBD. Ultimately, it was because of these great BBDers that we were able to successfully deliver this product. Combined intelligence just goes to show the power of working for a company such as ours. So let's get our hands a little dirty. Soon. Sorry, slight delay. Let's say we want to build a new online store. We want to sell vintage bottle caps. What I want to take a look at is the infrastructure around such an application. Getting started is pretty easy. We can install serverless framework through NPM, which is a package management library for JavaScript, similar to NuGet for C# and Maven for Java. The project structure shouldn't look too dissimilar from many other projects that you work on. At the root level, we have a package.json, which tells NPM which packages to install. We have an ESLint file here that applies strict rules around formatting our code. This is so the whole team adheres to a very strict, easy to support code style. We also have deployment scripts, which are scripts that we write to extend the built-in deployment capabilities of serverless framework. These are all fairly typical of modern software projects. Something that isn't typical, however, is the serverless YAML file. Let's dissect it. This serverless YAML file should serve as the center for any serverless project. First, let's take a look at the custom tag. Many of the general configuration and global properties are stored here. Some of the items we specify here are also items that we frequently use throughout the rest of the project, so it makes sense to parameterize them. We can also set up the virtual private cloud or VPC configuration here. Think of VPC as the VPN your services need to connect to access the resources they need to get the job done. These can be set on a project level or at a function level later on. Next, we have the plugin configuration. This is where we set up our plugins to work with us and not against us. So remember when I said we can deploy to many different cloud providers? This section in our config is what allows us to do that. By adding these additional cloud providers to the config file, we also set a bunch of options here that are specific to the cloud provider or the account we are using. This would include which region we're targeting, the memory allocation for functions, we can set at a global level. Again, we can set that later for individual functions, and which runtime we're targeting. So, which language, which version of which language we'll be working with. We can also set up our gateway here. So if you think back to our previous snail mail example, the gateway would serve as the post office, which gets new requests and decides where they have to go. We can also enable tracing here. So tracing allows us to see when someone attempts to buy a bottle cap. We can see when that request came in, which services it spoke to in the background, and the overall status for that request. Very handy for debugging. Serverless deployment also creates zip files as artifacts for use in the deployment process. This section of config allows us to tweak settings around that package and explicitly include or exclude files and folders. The plugin section allows us to see which serverless plugins we'll be using. These have been very handy for enabling offline testing of online cloud components. We rely very heavily on these to get the job done and was one of the main draws for looking at serverless framework initially. Speaking of getting the job done, the next section is where we define our functions and how we interact with these functions. Typically, a function would have a name, and we'd point it to the logic, that the files that would serve as the logic for that function. Then we have the events. Events let us set up how our system interacts with these functions. A trigger is a resource that we can configure to invoke our functions by lifetime events, external requests, or on a schedule. We mainly use three types. HTTP functions are functions kicked off by the API gateway when someone makes a request. For our example, this would be someone making a request to buy a bottle cap. SQS functions are functions triggered when messages with a certain topic lands on the queue. These events aren't time sensitive, so maybe we want to update our user on the status of their purchase. We could make use of SQS functions for this. Invoke functions are functions that get kicked off by other functions. However, these are a big no-no in our rulebook. Why? Well, because of cascading timeouts, of course. Having functions, calling functions, increases the risk of cascading timeouts. So let's imagine we have a scenario where the user wants to bid on a rare bottle cap. After the user makes the request to bid on the bottle cap, the first function gathers information on the user and sends that off to a second function. That function checks that the user is in good standing and has enough credits to make a bid on the bottle cap. This information gets sent off to a third function. Our third function calls the orders API, which is super busy, as you can imagine, this being a bottle cap store and all. Each of these functions have a 30-second timeout. The orders API might be very busy and only resolve its request at the 29-second mark. At this point, the first function in our chain would have already timed out and given our user an overall error message. This is cascading timeouts. This is where people might be tempted to use state machines, but for most scenarios, you're compensating for bad design. It might be time to take a step back and review your solution. Serverless not only allows us to deploy functions and the events that support them, but also the infrastructure around them. It has the ability to provision and configure most commonly used cloud components. And luckily, if there are resources that you need to provision that fall outside of these commonly used resources, Serverless allows you to provision these using your cloud provider's native infrastructure as code solution. In our case, this was AWS CloudFormation. Writing additional resource scripts is not something you're likely to run into. And even then, the community is constantly working on plugins to make this experience as palatable as possible. A couple more things that we've learned that isn't touched on in the YAML file. Because serverless projects are very config heavy, it makes sense to look at a monorepo solution. Simply put, a monorepo is a single repository containing multiple distinct projects. This way, you could have config shared across multiple projects at the root level and have specific configs for specific projects in that repo. With this approach, the next time you need to change the global memory used for a function, you can make 1 PR instead of 14. Sorry, Raymond. So where to from here? I hope that this talk leads to two things. One, that you're eager to look at serverless architecture. The next time you look at a problem, you ask yourself, is this a problem for serverless frameworks? And two, that I've shed some light on serverless framework. I think the approach has gotten a bad rep lately because people have been trying to force it where it doesn't belong. So mess around with it a bit and you're likely to find yourself with a new tool in your belt. Thank you. Question time. Yes. Okay, so we did look at Terraform. It was one of the alternatives. However, for us, the local experience for developers, you need DevOps engineers or platform engineers to write Terraform. I can wrangle a bunch of JavaScript guys together and they can write a serverless project. It's YAML at the base, it's whatever you use, and obviously we use JavaScript. We actually recently, for the client we're working on, there's a very, very big rush towards the end of the year. We needed more people writing functions, and we could pull people in that had no experience working with serverless, and they were able to do this. So I think it's a skills thing. I'm not going to get a Terraform guy, a good Terraform guy. We've seen, bad Terraform people. You're not going to get good guys behind every bush. I can force people to write good JavaScript with a proper ESLint file, hopefully. But yeah, that's a skills issue. Anything else? You can. So we do it. There are instances where I need to write to the DB and I need to know immediately whether or not that was successful. So you can do it, but then we try to write to Aurora DB, DBs where we don't have to manage state and all that kind of stuff. But what we have tried doing recently, especially now that the client's kind of bought into the model, is eventual consistency around our DBs. So we throw messages that need to be written into a DB, throw it onto a queue. Eventually, a Lambda will pick that up and do the DB change. But again, that only works when your system is asynchronous. If your system isn't asynchronous, and unfortunately, our first project has a very synchronous front end, So we have had to cope with that. So some of the no-nos, so don't call a function with a function, we had to do that. Don't compensate for bad process with step functions. We had to do that. But that was the first generation, the first attempt. From there on, we've gotten buy-in from the client to do these things asynchronously. Cool. So when we started, it was pretty difficult. We could emulate functions locally. We could emulate DB locally, but that was pretty much the extent of it. So luckily we started out in a position where we weren't really doing asynchronous all that much. So we didn't have a heavy reliance on queues. But as we've moved on to new projects, queues have become a big focus of what we were doing. So the community actually came out with a plugin that allows us to emulate queues offline. So you have a little console that you can run, or you can get onto your queue. You can see the messages that are currently on the queue, how long they've been there. You can emulate dead letter queues, all that stuff. So it's pretty cool. The plugin library is freaking extensive. So anything that we have pain with, someone is trying to solve. And actually, Matthew Pilkington has written a couple of our own plugins. So spots where we saw, oh, hey, this isn't working for us. What can we do to fix this? Instead of just making a small solution, he created a plugin. We can obviously push that to contribute to the community. Oh, yeah, online questions. In-person questions first. Yeah, so not to throw anyone under the bus, one of the people I did speak to before we attempted serverless was a team in BBD that went with a serverless approach and then almost as a crutch figured out that the back processes weren't asynchronous. So they had to compensate for that. So they put step functions in place. And when they started doing that, they started noticing all of the issues you'd expect to start experiencing with no step functions. It gets super complicated. There are instances where you do need to use it if you've got multiple processes that need to happen. But I always caution the team, if we're putting in a step function, we probably missed something somewhere. So we try to either influence the front end or whoever's consuming. We try to influence that so we can make the process asynchronous instead of a synchronous process. But if you can't get away from the step function, it's still there, but it's a nightmare. It was also one of the things we couldn't emulate early on. So there's a plugin that allows us to do that now. From a cost and stability point of view, which one is better, serverless or Kubernetes for high traffic enterprise applications? I would be able to answer that for you if I had a lot of experience with Kubernetes, camera person. But unfortunately, I don't. I can't really speak to that. But I'm sure we can chat to someone like Ricky to get a good view for that, yeah. Okay, no more camera people. Anyone else? Another one. Okay, start challenge and service framework. Yeah, that's a good question. What do you think about serverless cold start challenge? Okay, I know where this is going. Okay, so we actually, again, we ran into this recently. So you can provision some of your functions. Obviously, we work in AWS. So you can provision functions to not have a cold start, so they start warm. You do pay for that. The more you need to do that, the obviously more expensive it gets, and the less likely it is that serverless is the right solution for you. So it's not if you do serverless, then you only do serverless. If you find that cold starts are an issue for you, maybe you're trying to force a solution. So for me, that's kind of the issue there. Same question. Cool. Okay, well, I'll check what the question is now, if it comes back. Anyways, anyone else have? We're getting close to it. So it's like typical software engineer process. We end up having to do things manually a lot of the time. we get irritated with that. We start writing template projects and ways to do that very simply. Okay, that started halfway through. So no, but I'll get to that just now. So back to your question, which I don't remember what it was now. Oh, yeah. So we are getting to that point because we are getting fed up. Like I said, the amount of times I've had to tell Raymond to make 14 pull requests to get to our 14 repos. Raymond will probably give me a flippant scathing review, which is around the corner. So maybe you might not see me here next year. But every time we need to do these things, we try to automate these processes, we try to make them simpler. So our next focus is getting to that point where the boilerplate stuff, easy, we can do it. And the stuff that we are going to be focusing on is the business logic, the functions that need to be deployed, the functions that need to run. Everything else that you can kind of abstract away. The question about, do I see a future where everything is serverless? Definitely not. There are processes that aren't asynchronous. As long as we have synchronous processes, as long as we have stuff, it's really quick. It's really good. The use case for serverless is I have a front end. There's services that exist upstream. I need some way to talk to them. So the traditional spot where you see your BFFs, that BFF falls away, that becomes a serverless application. Because you don't need to keep state. You need to talk to something in the background, update a status somewhere, and then you need to give the user a response. So yeah, I don't see a full serverless future. It does, but we had the opportunity to work with the AWS technical account manager, and that was very enlightening. A lot of the stuff we did that we thought we were super clever, he came out and said, no. The important thing around serverless is your functions need to run for as short as possible. So do what you need to do to have that function, have everything it needs to do, get its job done and drop. So no, I suppose that's my take. I don't know, are we on time? Are we still okay? Okay, cool. More questions? Mm-hmm. Mm-hmm. So the example I like throwing around is the Mr. D food delivery app. So I want to make a request and I don't care about the process. The user wants to make a request and then do whatever they want to do. And then in 5 minutes time, they realize, fuck, I'm hungry. Check, oh, okay, PT is driving and he's going to deliver it soon. That's where you want to get. If you can get your front ends to be asynchronous and what WebSockets or whatever you want to use there. If you can get your front ends to be asynchronous or your consumers to be asynchronous, awesome. You will still have other microservices doing the heavy lifting. We're never going to get away from that. That's just not the use case where serverless shines. You're setting yourself up for failure if you want your serverless functions to do all that work. Anything else? One more online, another online. Have you come across a need to do RBAC enforcement on API gateway or Lambdas? I'm going to level with you. I have no idea what RBAC enforcement is. Role-based access control. Okay, so no, we haven't had to do that yet. But something I didn't touch on that we do on our API gateway level is, so for AWS, you have a certain tier of free invocations for your functions. What you want to do is you don't want functions to get invoked if they aren't actually going to do anything meaningful. So you don't want to do your validation in the function. On API gateway, you are able to do that validation. At the moment, it's still fairly simple. So we just do the validation. If you don't meet the contract, we're not going to spin up a Lambda because you're costing the client money by sending nonsense. And I think everyone's lucky. Tabang's trying to kill me. He's sending me death threats. Cool. Thanks so much, everyone. Hope you have a good day.